So where we're headed in class is that we're going to start working with vectors. And before we start working with vectors, let's go back and review a little bit of trigonometry. So it's just some fundamental things from trigonometry that basically come with dealing with right triangles. So of course a right triangle is a triangle where one of our angles is 90 degrees. So here's our right triangle. And this leg and this leg of the triangle are perpendicular to each other. And so we're going to label these two legs A and B. And then the other side, right, the side that's opposite the right triangle, that's called the hypotenuse. So here's our right triangle. And so there are four things that we sort of want to make sure we're really comfortable with in terms of dealing with right triangles, the first of which is the Pythagorean theorem. And so the Pythagorean theorem is a way to calculate, or to relate, I guess, the length of the three sides of your right triangle. So Pythagorean theorem says that the length of side A squared plus the length of side B squared is got to be the length of side C squared. So what we'll often do in terms of thinking about the length of the hypotenuse of a right triangle is we'll sort of rewrite this in terms of C is equal to the square root of A squared plus B squared. And we'll see that this form is something that we'll use quite often with vectors. All right, the other three things that we're going to make sure that we understand are our trigonometric functions. So the first thing that we need to pick is we need to pick an angle. And so here I happen to have chosen this particular angle down here, theta. So what this means is by basically drawing in, and we always draw in our angle from the hypotenuse to one of the legs. And so the leg that we've picked here, that we've drawn our angle into, that becomes the adjacent side to our angle theta, and B becomes the opposite side to our angle theta. So in the same way that C is opposite the triangle as our right triangle, B is now opposite the angle theta. And so knowing that, we can go through and set up our trigonometric functions. So again, here we've got the cosine is defined to be the adjacent side to our angle theta over the hypotenuse. So cosine theta, in this case, would be adjacent side A over hypotenuse C. The sine function, so sine theta, is the opposite side to angle theta divided by the hypotenuse. So in this case, the opposite side is side B, so this is going to be B over C. And then the tangent of theta, to get the tangent of theta, we take the ratio of the opposite side to theta to the adjacent side to theta. So this will end up being B over A. Now the reason we sort of added these 2 theta, 2 theta, 2 theta is to emphasize that there's actually a choice. Right? We could pick a different angle. So if instead of picking theta over here, we pick this second angle phi. Well, now what we've done is, so again, we've drawn in the angle phi from the hypotenuse to one of the legs. In this case, we happen to have drawn it into the leg that we've labeled B. So now B is the adjacent side, A is the opposite side here. Okay? So if we want to think about the cosine of phi, well, now I want the adjacent side to phi, that's side B, divided by the hypotenuse. So notice that my ratio here is flipped around. This is B over C rather than for theta where it was A over C. Sine phi, I want the opposite side to angle phi. Well, the opposite side to angle phi is A. Divide that by the hypotenuse, so the sine of phi is going to be A over C. And then tangent, again, same definition, so I want the opposite side to angle phi divided by the adjacent side to angle phi, so this is going to be A over B. So what you notice is, by switching my angle, a couple things happen. One is the cosine of phi is exactly the same as the sine of theta. And the sine of phi is exactly the same as the cosine of theta. So basically by choosing the other angle, I've switched the sine and the cosine. The other thing is with the tangent, this flips over. So the tangent of theta was B over A. The tangent of phi is A over B. So part of what we're going to have to pay attention to is just making sure that which angle have we selected is going to dictate which side we need to pay attention to in terms of thinking about the sine or the cosine function, or which side goes on top in terms of the tangent. So those are the four basic things: Pythagorean theorem, cosine, sine, and tangent. So the four basic definitions from trigonometry that we're going to use very often in dealing with vectors.